Now we want the probability that Ken orders Alfredo, which is not given above, all right? I have Alfredo givens, all right? So you gotta think there's 3 cases here. One, he orders it from Olive Garden. He can go to Olive Garden and order it. Another case, he can go to Red Lobster and order it. Third case, he goes to Applebee's and orders it. So one of these things has to happen. All right, so the probability of Alfredo, all right, this is ordering Alfredo, is either it's the probability of that he goes to Olive Garden and orders Alfredo, or he goes to Red Lobster and orders Alfredo, or he goes to Applebee's and orders Alfredo. Now, are these disjoint? Is Olive Garden and Alfredo disjoint from Red Lobster and Alfredo? Right? And so the question is, can I, on one given night, can I do both of these? I guess he could go to 2 restaurants, but no, it only says I choose 1 restaurant with these probabilities. There's no event out there where I choose 2 restaurants and go to 2 restaurants. So these are disjoint. So all 3 of these are all disjoint. Only one of those can happen. So that means if I want these probabilities, I can add the ors. All right, so when I see these ors and they're disjoint, I just add them. Always with an or I can add, but I have to subtract overlap, but there is no overlap here. So this is going to be probability of G and A plus the probability of R and A plus the probability of B and A. And this is by the addition rule for disjoint events, or mutually exclusive events, either one. All right, so now if I want to get this, I use the probability of G and A. I need the multiplication rule for that. So this is always going to be equal to the probability of G times the probability of A given G. Plus, same thing here, probability of my restaurant times the probability Alfredo given Red Lobster, plus the probability that we go to Applebee's times the probability orders Alfredo at Applebee's. All right, so I listed all these above. All right, so I've got the probability of G, R, and A, that's 0.25, 0.33, 0.42. All right, and then A and G is 0.85. A given R, 0.56. A given B, 0.71. And if I multiply those out and add them together, I get 0.6955, which is about 70%. So every time Ken and his wife go out, there's a 70% chance he's going to get Alfredo.